Okay. We're going to go over these problems. Once we're done going over these, I will answer any questions that you have for the homework/classwork. Then I'm going to collect them. Okay. And we have a pretty straightforward, I'd like to think, lesson for today. And just like to remind you guys, you will have a quiz next class. And it will be over basically this type of warm-up and what we're doing today. But the good news is that what we're doing today, we've actually already done before. Okay, but we're going to treat it as if it's brand new. So that's kind of nice. I mean, I'm not saying that you've done it in Algebra 2. I'm saying we did this already. So it's going to be a nice refresher. All right, so let's take a look at the answers for this. Let's see if it's not up. Helps if I've actually pulled this up. I apologize ahead of time because my projector has been freezing a bajillion times today. And that's the technical term for it. It has been a bajillion times. All right, so let's just focus here first on the first 4 problems. And then we'll look at the other 2. And by the way, for problems number 1 and 2, I'm perfectly fine if you wrote S over 2 and T over 2 or T over 3. It's the same thing. I'm okay with that. And I've got 2 different ways that I would have accepted problem number 1. Although, frankly, you should always distribute and tell me what it's equal to. Taking a look at that, let's see if we have questions. Yes, sir. Because it's not the square root of x squared, it's the square root of x squared plus 1. For example, 4 is something squared. 4 plus 1 is 5. I can't just cancel that out. You cannot cancel it out. You can factor it, but it's not factorable because it's got that plus sign. Yes, ma'am. Yes. The question was if you left this as log of 10x, because this is 10 times x, and you need to take a hint from the denominator here that it is 10. I mean, if I had, for example, log of 53, and there was no x or anything like that, I wouldn't try to break that down into something. But because the base is 10, and that's a variable, I do want to separate that as much as possible. And again, that 1 came from the log base 10 of 10. It's equal to 1. Okay, good questions. Yes, sir? You can't, because if you think about it, when we look at our properties, I can't move down from subtraction. Okay? A lot of people try to do that, but then you also want to make sure that if I worked backwards, I would get back to that piece. Anybody else for those 4? Okay. Let's take a look at 5 and 6. Now I will work these out and answer them if you need to see them. I know number 6 is a little bit weird. I just want you to know that when I pull that 3 up and say sine of 2x, that whole quantity cubed, any power sits next to the sign. Okay, just kind of trying to clarify that a little bit for you. It's not like you're having to remember any of your double angle properties or any funky thing like that. Just know how to write where the powers go for sines, cosines, and tangents. Yes, ma'am. Where does the 100 come from? The 100 comes from the fact that every piece has to have a log. And looking at this way, in order to get a log, I'm going to put log of 10 because log base 10 of 10 is equal to 1. And then when I bring the 2 up, 10 squared is 100. Okay. Any anybody else? You guys are just so excited to be here today, or you're just like killing it? Hopefully both. Yeah? No? Notice that today. Everybody's been a little bit blah today. Hopefully we have a little bit of caffeine during lunch. Sorry, I had a little bit too much caffeine this morning. I probably had a quarter cup of coffee, and that's a little bit more for me than I should take. So I'm buzzing a little bit still. Talking a little fast. Don't know if you noticed. Yeah? I don't talk fast, do I? Kendra's like, what? Yeah, no. We've got a little bit of zoning going on in here, across the board. All right, so let's take a look at the homework then. And I will answer any questions you guys need. I am here for you. Yes. 27. 27 is a bit of a booger. And I just want to say, before I even pull that problem up, know that I'm not going to be giving you numbers that crazy on a test or quiz. Because my goal isn't to see, do you know how to break down 486? That's absurd. Nobody's got time for that. So what we do for a problem like that is we look at the numbers that I have to use. I can use 7. I can use 9. I can use 12. There's also one more number I can use. What's that? I can use 10. And so what I'm going to do is I'm just looking here at that 5. Can I make 5 out of 7, 9, or 12? No. Can I make 5 out of 10? Yeah. So if I make that 5 to be a 10, what would I have to do with the denominator? I'm going to have to double it, and that would make it 972. And for the love of all things mathematical, I'm busting out my calculator for this because ain't nobody got time for that. And all I'm going to do is I'm going to take 972 and I'm going to see, can I divide it by 7? Nope. 972 divided by 9. Yep. If I divide it by 9 again, woohoo! So I can see that this is 9 times 9 times 12. You okay with what I did there? Just trying to break it down. And now that I have 9 times 9 times 12, I can translate that into, that's going to be the log of 10 minus 2 logs of 9 and minus a log of 12. What is the log of 10? 1 minus 2 v minus w. Okay, do not switch to variables until you can physically see that chunk, that entire chunk by itself. Okay. Yes, sir? 14. Let me see what that problem was. Yerp. So if we're looking at 14, laws of exponents can be handled in many different ways. I'm going to do this in the way that makes me deal with the least number of rules. And what I mean by that is I want to make this simplified first. So if I simplify that, that's the natural log, and it will be 3 to what power? Not 3 to the 4th, 3 to the 20th over 10 to the 4th. So that means when I start breaking it down, I will do the top minus the bottom. So that will be 20 ln of 3 minus 4 ln of 10. Can I cross out ln of 10? No. Why can I not cross out ln of 10? Because this is base E. You would only be able to cancel it out if it was base 10. Okay. I couldn't find my answer key, and if it was crossed out, it was wrong. Thank you for bringing that to my attention. Any of the other ones? Yes? Exact same steps for what we just did. So it would be 11 to the 4th, 7 to the 20th. So 4 ln 11 minus 20 ln 7. Exact same steps. Okay. All right. Well, yeah. Number 2, if I can find it. We will do that after the lunch break. For number 2, let me kind of backtrack a little bit. Well, it doesn't matter because my screen is frozen. I told you that would happen. Wait 1 second. Oops, wrong button. Okay, so before I look at number 2, I want to kind of back up and look at number 1. And the reason for that is, number 1, we can kind of think about what power do you raise 3 to get 1 over 27. And so for that, we don't really need much additional work. For this, I think they both have 6's in common, but then it gets a little weird. This isn't something that I really expect you to know by looking at it, is the point that I'm trying to make here. So what I do is I say, if I can't look at it and do it, try rewriting it. So I would rewrite this as 216 to the x power is equal to 36. Once you have that, then get each of these into a common base. I could write both of them as what? 6. So 216 is 6 to what power? 6 to, is 6 to 3rd? It's this, let me see here. So I think it's the 4th. Nope, it's the 3rd. You're right. And then 36 is 6 to what power? 2nd. So because my bases are the same, if I simply look at my exponents, I can ignore the rest of it. What would I do to 3 and x? Is that add or multiply? Multiply. So that means 3x equals 2. So my answer is 2/3. I got 3x from right here. Right, when your bases match, you can really just look at the exponents. Yes, sir. Okay. I'm going to actually write 11 out because I have it pre-worked over here. Well, here, I'll walk through it. So we talked in class about how if you see that log v over 3, that's the same thing as 1/3 times. Are you okay with that? And then any multiplier I'm going to pull to the front. So that means I pull the 5 up to the w. Just like on this piece, I'm going to pull a 1/3 up on top of the u, and I put the 1/3 up on top of the v. Now both of these have 1/3. What's another way of thinking about 1/3? Cube root. Beautiful. So addition becomes multiplication. So I've got w to the 5th times. Both of those have the same root, so we write them together under the same radical. Do you got that? Yes. When we do this, the standard way of dealing with exponents is we write all of our fractional exponents as radicals. The only time I want to see a fractional exponent is if it is specified to you. Otherwise, give radicals. Okay? Anybody else? Yes, ma'am. It's okay. You just, okay. All right. Like I said, we've got time, guys. Questions are okay. All right, then. Make sure your name is on it. So please don't cry. Please, I'm begging you. Don't cry, just cry. why I get a huge kick out of that, but I do. Don't worry, it doesn't need to be like 100% accurate. Like I'm not expecting you guys to make your own graph paper here. I just want you to do a quick sketch of what this is. The focus here, ladies and gentlemen, is on these three things: the domain, the range, and the asymptote. The graph will help us answer that question. Okay? So do me a favor and graph that. If you have completely forgotten how to do this, it is really important, guys, that you kind of say, look, I really did not remember how to do this. I need to work on this. There's nothing wrong with admitting the fact that you have something you need to work on. All right, let's think about the parent function for this. We'll start with the very most basic. We'll say we've got y equals log base 2 of x. If you have completely forgotten how to graph a log, what can we do to make this simpler? 2 to the y equals x. Beautiful. Just rewrite it as an exponent. Then I'll be putting in y's and see what I get out. So if I put in 0, that means I'm not moving up and down. 2 to the 0 power is 1. Put in 1. 2 to the first power. 2 to the second. 2 to the third. Okay, and I'm off the grid going that way. Let's go negative. 2 to the negative 1. Negative 2. And it's going to just keep getting closer and closer to that line. So this here is my parent function. That's what my log function for base 2 looks like. Now, what I've done here is I've done a transformation on this. We've done a shift. Which direction is my graph going to move? Left 3, up 1. So basically what that's doing is that's making this spot right here my starting point. That means when I graph, do the zeros 1, the first power is 2, second power 4, 1, 2, 3, 8, and then we've got a half, kind of coming down this way. So that's what the transformed graph looks like. And really, again, the focus for this is to be able to talk about domain, range, and asymptote. Domain. What variable does domain deal with? X. So domain is left to right. How far to the left does the graph go? Do we touch negative 3? No. How far to the right does it go? Do we touch infinity? No, you never reach infinity. So if you wrote it as interval notation, that's what you would have. Set notation, we would say x, such that x is greater than 3. Negative 3, thank you very much. Okay. So if the domain is the x, the range is the y. How low does it go? Negative infinity. Do we touch negative infinity? How high? And we don't touch that either. Or if we were doing this in set notation, we would say y such that y is in the reals. Any real number will work. And it's that kind of, almost looks like a C with a line through it, almost like an E, almost like a euro symbol, kind of similar to all of those. And an asymptote. An asymptote is a line that I approach. Is my asymptote going to be vertical or horizontal? If I do horizontal, it's going to keep going up, just slowly. But if I do vertical, it's not actually going to cross that. So how do I write the equation of a vertical asymptote? How do I write the equation of that? X equals negative 3. Good. Now, what you need to understand about logs and exponents, logs when it comes to domain and range, that's that no matter what your log that you are given, your range is always going to be all real numbers. So we're not even going to worry about that. The range for a log is always all real numbers. Another really cool thing that happens here is whatever number we have here, that number will always match that number there. Okay? They're always tied to each other here. And the only thing I need to think about for the domain, because that 1 did not affect it, all I need to worry about is what I'm taking the log of. And what's going to be true about what I take the log of? This has to be greater than 0. Okay? So back in the day when we were graphing our functions, we talked about the domain and range of all of our functions, and we said when we talk about a log function, if I have y equals log to any base, I don't care what the base is, of x, where x is the stuff inside my log. I don't care about anything else. If x is inside of that log, then your domain comes from the idea that that x has to be greater than 0. There is no power I can take a number to and get 0. 6 to no power, never going to get 0. Never going to get a negative number with them either, so that's why we have greater than 0. And ladies and gentlemen, that's the idea behind today. The hard part for today is not this. The hard part, and again, we've done this. It's okay. We've done it before. We're going to do it again if you've forgotten, is how to find these domains. So I want you guys to write down problem 1 for me, please. The whole idea behind this lesson is based on a very, very, very simple concept. And it says, if I'm looking for domain, all I care about is what I'm taking the log of, whatever that is. And the fact that you have to know is that whatever that is, it has to be what? Greater than 0. So that just means I have to solve an inequality. And that is the hardest part of what we're going to do today, because sometimes it does get a little tricky. So that is going to tell me this is a basic simple solve. X has got to be greater than 1. So when we're doing domain, you can either write it and say x such that x is greater than 1. And it's a domain, so we'd say that it's the set of all x's such that they are bigger than 1. If you are going to do interval notation, since x is bigger than 1, would 1 be the lower or the highest it could go? Lowest. So that's going to be my left number. The other number is going to be infinity, and they're going to be parentheses. Everybody has preferences on which to use and when. I really don't care. I do care that whatever you do choose to use, that it's accurate. Okay, that just goes to show that the idea we're talking about, this thing is greater than 0, very straightforward. Now we get to why we're even bothering practicing this. It's because sometimes inequalities can be harder to solve. So go ahead and write down problem number 2. Just like with problem number 1, I don't care what the base is. I don't care if there's stuff hanging out outside of my log. All I care about is this stuff right here. What has to be true about that stuff? Has to be greater than 0. There will be 2 answers. And we're going to talk. Nope, there's something that we're going to do for that. We're just wait, we're going to do it. He's so excited. In order to solve this, first we're going to pretend that that's an equal sign. If that had been an equal sign, what would you have done? How do you solve? Factor. When you have a squared and a not squared, you are going to factor. How does that factor? Good. X plus 2, x plus 3. Had that been an equal sign, you would have gotten what number for x? And you would have gotten -3 from that piece. Was that an equal sign to start with? No. Everybody listen, this is extremely important. Do not just turn this into x is greater than -2, x is greater than -3. That will almost never work. Okay? To do this, use these two numbers as your starting point. Which number is smaller? -3. You remembering doing this? Way back at the very beginning? If not, that's okay. Do I include -3? No, because it has to be my original sign here. This is what I'm trying to solve, is that it has to be greater than. This is technically a greater than here. So that means I will have an open circle on both of those. I will not be able to use either of those numbers. There are two different ways that you can solve this. There's actually a bunch of different ways. I can think of 3. The one that people generally start with is they pick numbers that are easy to substitute in. And I always look to see where would 0 fall. Would 0 be left, middle, or right? So I'm going to plug a 0 in. You can either plug it in to the initial problem or your factored one. It doesn't matter. I think 0 is easiest to plug in here because what do you get? 6. So at 0, I get 6. Is 6 bigger than 0? So that will be part of my answer. Two and 3 are really close together, so I'm going to go over here. I'm going to just pick -4 because it's the next number. Next number down, that is. When I pick -4, I'm actually going to plug that in here because that's a lot easier than squaring and timesing it by 5 and adding 6. So what is -4 plus 2? -2. What is -4 plus 3? What is -2 times -1? +2. Is 2 greater than 0? That's 6 down here. So we know that area works also. And then just pick a number in between. I would say -2.5. And again, believe it or not, I would plug it in here because I don't want to square 2.5. My brain starts hurting. What is -2.5 plus 2? What is -2.5 plus 3? .5. A negative times a positive is a? Is that bigger than 0? No. And when I look at this, out here is going to be my -infinity. Out this direction is +infinity. So I am going to say that my answer can go, because that's a good place, I can go from -infinity to -3. I can't have this. I can pick up again at 2 and go to infinity, and what symbol goes in between? Union. You can write it like that. Or if you like to think about it in terms of what the graph kind of looks like, some people feel more comfortable saying x such that over here, x is less than -3, over here, x is greater than -2. Do not say that x is like that. That's not appropriate ever. Only time you write it between is if it literally is between. Okay, did that step make sense for you? Literally picking values and plugging them in. I'm lazy. That's too much work for me. I take pretty much that approach, but I don't bother about plugging it in. I just say, would it be positive or negative? If I took 0 and plugged it in, it would be 6. I don't need to think about that too much. You okay with that? All right. If I picked -2.5 and plugged it in, all I need to think for this, if I plug -2.5 in, would it be positive or negative? Negative. If I plugged -2.5 in, it would be positive. A negative times a positive is a negative, and that's all I really care about. I don't care about what the exact value is. I really only care about the signs. Same thing here. If I plugged in -4, that would be a negative. That would be a negative, so the full answer is positive. That's all I care about. Yes? It is not always going to be the union. It is not always going to be on the outside. It is not always going to be on the inside. You have to check to see. The other way you can think about this is actually the way that I do it, is I go, okay, I've got a number line here. I'm going to have zeros. Does that graph open up or down? Up. That graph opens up, and it is bigger than 0 on those parts. So that's literally how I do it. I don't care which of those methods you use. You just use whatever works for you. Okay, let's do another one. Go ahead and write down problem number 3 for me. Main idea. How do I do a finding domain for log? What did we just say here? What was the very first thing that I did? Say what? Not equal to 0. Bigger than 0. So I'm going to take this stuff here, and I'm going to say x plus 2 over x minus 2. That thing, whatever it is, it has to be bigger than 0. So where we start, where we always start, is finding numbers that make it 0 or make it undefined. What number could I plug in here to get 0? -2. So I'm going to have -2. And what number would I plug in here to make it 0? 2. So actually I'm going to write these down here. So the smaller one goes on the left, bigger one goes on the right. Everybody okay with where 2 and -2 came from? Again, when you're talking about a quadratic, it's what makes either of your factors 0. When you're talking about a rational, it's whatever makes the top or the bottom 0. So you need both of those. Again, they're going to be open circles because that symbol is greater than. It's not or equal to. Now I'm going to do this one just using the sign method. Okay? You can do it with numbers. I think the sign method is lazier and awesomer because I'm lazy and awesome. So there you go. Where would 0 be? Left, middle, or right? Middle. Always the easiest number to plug in. If x was 0, I would have a positive over a negative. What's my answer going to be? Negative. All I care about is the sign. I don't care about the value. And is that going to be bigger than 0? Nope. That is not part of the answer. And then let's just think about a number on this side. Let's pick 3, because I can. If I put 3 in here, would I have a positive or a negative? Positive. If I put a 3 in here, what would I have? A positive. And a positive over a positive? Is that one okay? You see, I don't even really care about the numbers. I just care about the signs. Kendra, are you all right with that? I just couldn't read your face, that's all. Just check and make sure you're okay. And if I did -3 over here, I would have what for the top? A negative. Junior, wake up. And what for the bottom? And a negative over a negative is a... So that would have also worked. Again, it is just by chance that these guys have been on the outside. Do not always put it on the outside. And again, you can do it using intervals. Using intervals, what would my first interval go from to? -infinity to -2. Then 2 to infinity, and what do I need? You need a u. And you need to put it so that you always move from smallest number to the largest number, always. Or if you wanted to do it set notation, or I'm sorry, this is interval, this is set, I would do x is less than -2, x is greater than 2. And be done. Okay? Hard part here is the algebra. It kind of stinks. We're kind of in an algebra 3 moment right now, where we'll spend a lot of time in an algebra 3 moment. All right. I want you to do 4 and 5 on your own. Okay, so let's take a look at the answers. Here is problem number 4. Starting with problem number 4. Ladies and gentlemen, please notice what I did not do. Please do not just say, okay, x squared is bigger than 4, so x is bigger than 2. You're missing a lot of your answer. Does that make sense? Don't do that. Are there questions on this one? Because even if you said plus or minus 2 here, you're not actually greater than -2. You're less than -2. Okay, and then for number 5. Very difficult to read your faces today for some reason. No, that doesn't mean you need to look goofy and happy all the time. Just can't even tell if you're confused. Questions on that? Yes. So you got the number line. All right, so if we're looking at this point here, you know that it's not on this side, it's only in the in-between. So the interval is kind of easy to do. You just say, if it was before, I think about that as -infinity and positive infinity. And if I had a check, I would say it starts here, goes to this, union, whatever. But I'm not here. I start at this point. I end at this point, and they're open circles, so they're both parentheses. Or if you're talking about where your answer is, my answer is in between here. And those always have those symbols that go with it. Okay? If I leave that there, someone's going to get confused. Okay? Can we do one more? You can do one more. One more, this will be it. And then I'll give you guys your homework, and you'll have a half hour to basically work on that. Oops, helps if I'm recording. Your answer here should be Hey! I love it when they all do that all together. Hey! Does everybody understand? Yes. Yes, because that is your basic for quadratic. And so when I look at this, hey, be nice. When I look at this, I think about it not just as a parabola, because I tend to, again, I look for the easiest way out. I look at that and I say it's an upside down parabola. So it's only greater than 0 in the middle. And that's the way that I do it. But you do whatever you need for the work. So there's a lot of people who are like, I have to plug a number in. Okay. I have to see the value. Okay. I just need the signs. Okay. Yes, ma'am. Highest power squared. Quadratic. And then if the squared is positive, it opens up. If the squared is negative, it opens down. Okay? Yeah, I always look for the easiest way out. Sometimes it means you have to have better knowledge, though. Okay? All right. So, hello. Why did you just do that? We have a ton of time, and that's a great thing. So I'm going to write your homework up here. You have it in your notes, actually. Let's see here. If it ever opens up. Oh, it helps if I actually plug it in. Yikes. Does anybody have their outline with them? Because I don't have it handy. It's numbers. What page is today on? Yeah. Yep, 349, 29 through 50. Don't freak out. I know it sounds like a lot, but they actually go very quickly. Okay? So, I'm going to make you an offer, okay, guys? Some of you have your textbooks because you brought them in. I have 7 textbooks in the back of the room. Before everybody jumps up and runs to it, I'm also going to put my textbook up on the screen so that you guys can see it. I will freeze that, and I will give you the option, if you'd like to come up and take a picture of my textbook, you can. If you would like to take a picture of, it's just one page in the textbooks in the back of the room, you can do that. And you should make really good progress, if not complete this, before class is over. And you will see, here it goes. I'll make this clear. I know it's kind of hard to read right now. I know, I'm going to make it clearer. Okay, not much clearer, but some. Give me 1 second. I'm trying to do my best here. Okay, so I'm going to freeze this up here, ladies and gentlemen. You can squint real hard to see it. I have my book up here if you would like to just take a picture of it and work off of that. Again, I have 7 textbooks in the back of the room if they're not all gone yet. And ladies and gentlemen, what you see here, you see this problem up here? Domain. That's what we were talking about today. Evaluate. This is the expansion. And this is write it as a single log. This is what your quiz is going to be over next class. All that. So this is basically a practice quiz before your quiz. Okay? No. I'm sorry? It's right here. The domain and range, well, just domain is in here. And then you've got all the other bits and pieces. Yep, this is a review for your quiz next class. So please, you're welcome to work together on this. You're welcome to either, like I said, take a picture of the board, take a picture of my book, take a picture of somebody else's book. I would like to see you working, though.